Hello and welcome back to another festive coding session with Mr. Jacob. Today, on the 9th day of December, we will take another shot at our Advent of Languages series, where we strive to implement each day in the 24th days of December the same thing in another language. And what we are going to implement, as always, is something that outputs this ASCII art Christmas tree, or a sort of this tree, or a variant of this tree. And as we have done 8 different times before, today we will choose another language. And we have already done those languages, and today we will do it in Bash script. So let's, without further ado, get started. We are opening Vim and we are open our hello Xmas dot, let's call it sh. We are starting with a shebang line here, which will allow us to essentially go ahead and execute this later on as a simple command on the command line, so that the system knows how to actually interpret the script, or with which interpreter to start it actually. And then we can start right in. Bash script actually, or Bash, is usually your shell in most situations when you are using your command line here. Other shells that are typically used are something like ZSH, for example, or fish shell. It always is a kind of taste, I guess. For example, for my daily work, so if I create a new one here, this is actually a ZSH that we are currently in. So I'm using ZSH as my shell that interprets all my commands and for usual navigating. But I write sometimes Bash script because I'm quite familiar with it, and if I need to fast and easily script something down that I need to handle, I'm usually using Bash, because Bash is more or less installed on every system that I come across. So it is an easy choice for me. Okay, so now let's think about how we can actually create our draw tree example here. So first of all, everything that I would type in here, something like echo, for example, which is the command that is used to echo something to the screen, like for example, hello Xmas, would be executed when run. So let me quickly do that. Let me execute this command here. And as you can see, when I'm running this script, it supplies me with hello Xmas. So it does exactly what is here. So we do not need a main function or stuff like that. It's simply that what is in the body of the file is evaluated when it's run. Okay. However, we can define functions, of course. So what we can do is we can do something like, say, hello. And this is the syntax for functions, actually. You specify the name of the function, you specify brackets, and then you give it here the curly braces, and you can then put something into that function. And now if I actually execute this function, and you execute functions or call functions like you would any other command or any other command you would want to invoke from your script. So there is no special syntax like you do not use braces or stuff like that. You simply supply it like that, and if you want to supply command arguments, you simply would supply them like this. So you would simply supply them after the command you are calling. So let's see what happens if we do that. We still get hello Xmas. Okay, how is actually arguments handled here? Arguments are handled not by specifying them in the function declaration, but simply by using specific variables that are automatically set to given parameters. So those are actually simply the reference for a variable, which is always a $sign plus a number. So the first argument would be $1, the second $2, $3, and so on. So let's say we want to say something, we want to do something like this. We want to specify the second part. We could actually do this by easily saying, okay, we are using echo here. And now we are doing hello, and we are doing now a dollar sign to specify a variable. We can do this because variables can be used in double quote string interpolations as well. So as long as we use strings with double quotes, we can do string interpolation and simply add a variable name here, like for example 1, and then we could do an exclamation mark after that. And now if we run this, it should say hello Xmas again. So these are actually the basics. We could do it like that. However, then we would need a space between the exclamation mark and the 1 so that the system can actually determine that this is a variable. So you can either do them always with those curly braces around that to kind of escape their naming, or you could leave that away, but then it's always maybe a problem to embed them somewhere. So usually I do always reference them with curly braces because it minimizes errors there. Okay, now how can we define variables? We can define variables by simply taking them and telling them hello equals something like hello, and then we can use hello here. So that would actually be something that we could do. Let's quickly see that it really works, and as you can see, it works. Okay, now after having done some basics that are important because we are going to do a little bit of shenanigans with variables here, so I wanted to tell you those things beforehand so that you are at least not confused by the curly braces, because we will mix up curly braces and normal braces and maybe even brackets, and we will see to do some nice things there. So let's remove all of that and let's get started with our draw tree function. So let's do draw tree, and as always, let's put the number of groups there. And if you are not sure what I mean by groups, let's quickly go back to our initial README here and take a look at this, maybe even copy it out so that we can actually have some sort of reference here. That was the wrong thingy to do there. Come on. And now let's comment that out and let's remove the indentation that shouldn't be there. So now we have a little reference on what we actually want to do. And what I mean with groups are essentially those steps in our tree. So this one and this one and this one. So these different steppings here, and we want 8 of those, or at least currently we want. So let's define a draw tree function. And as I've already said, we are not specifying the taking of variables here, of arguments here, but within the body. We can simply use them. However, I like to actually name them. So I'm specifying now a variable, which I could simply name something like n, for example, and specify that I want 1 here, and I usually put them in a string there as well to ensure that we are not splitting things up in an unfortunate way if it contains spaces and such, which might be a problem in Bash scripts if you do it wrong. However, this would define actually a global variable called n. If we put a local in front of it, it is then local to this function. So I usually do it like that. And now I have actually a variable here called n within my draw tree function. So what do we now need to do? We need to kind of draw all of those steps out, and we want 8 of those. So we need some sort of loop. So we can actually do a for loop in Bash quite easily by using the for keyword, then the iterator variable there, like for example I, then an in, and then a list, something like, which is usually delimited by what the pattern matching of Bash actually usually splits things up in. So I could do something like 1, 2, 3, 4, 5, 6, 7, as space usually is a delimiter that is used. However, we need this dynamic. So we can actually call a function which is called SEQ for sequence, which generates us these things. And we will use inline command substitution. So if we do $ and a round bracket instead of a curly one, what we put in there is actually simply executed as a command. This can be an arbitrary shell command that you could type in your shell usually. And what that returns is actually embedded at this position. So if I do something like sec, and we can quickly see, let me open up wait, what? No. Let me open up a new shell here. And come on, if I do something like sec 10, as you can see, it will simply generate the numbers 1 to 10. So it's a normal bash command that we can actually use, and we can do something like sec n now, and we will get a sequence from 0 to n. However, what we actually want is we want a sequence from 0 to n minus 1. And that is something that we could do by using another bash, in this case, speciality, which allows us to do calculations inline, which would be 2 round brackets. And as you can see, this will get a little bit of crazy. That's why I started that slow. So we can do 2 of those brackets. So if I go back here and say, for example, I want something like foo equals 23. Okay, now we have defined our variable. And I tell it that I now want something like, give me an echo of this double brace syntax there. And I tell it that I want foo plus 42, for example. As you can see, it is calculated and then given back to us. And that's done purely within the bash interpreter without calling any external command. Like, for example, I could of course use BC for arbitrary precision calculation and stuff like that. But for the normal calculations, this is perfectly fine in bash script. So what I could do is I could put in there a dollar, 2 round braces there, and then n-1, and this would actually do what I want. Then I start the for loop with a do. So what I need to do is usually you would have this in this way. You need to have it in the next line. So for and then do, and it is ended actually with a done. However, you can either put things into the next line, which will tell bash that the command ends here and should be executed, or you can make a semicolon. So you can actually change, chain commands with doing something like echo foo, echo bar, or echo buzz. Yeah, or you could simply put them on different lines. However, the semicolon tells the shell that there is a command end here. So the usual style that most people do is something like you put this for part here, then you do a semicolon, and then you do, and then you go into the next line, which is usually what I do. So this is possible. There, furthermore, is another thing in bash that you could do. I could have done a kind of C-style looping here by using the round braces there again, however, without the dollar in front now, and tell the system something like, I want to do this like this and this. Come on, this would do exactly the same as the second line. So those are kind of equivalent. When I'm thinking about it, maybe we will use this style. However, this is quite bash specific. The other one is more or less, except for the calculation with the n-1 that we did there, is kind of POSIX compatible. Okay, so let's do this style, and now let's get going and draw out our tree here, or at least our tree groups, so this things here. And what do we need to do? We need to calculate the spaces here, or draw the spaces, better said. And then we need to draw a slash, then we need another set of spaces, and then we need a backslash. And how could we actually do that? In other languages, we used something like, for example, repeating spaces and commands for repeating them, or doing fprint f stuff, doing printf stuff to use formatting commands to kind of achieve that. We could call, for example, something like printf, because usually you have something like printf. If I check where is my printf here, we will at least even see that in bash it is, or at least in ZSH, it's a shell built-in. Okay, so I would assume that printf is a shell built-in in bash as well. So we may actually use that and do the same formatting. However, that would be kind of lame because we did that before. So let's do some variable magic in bash to do what we want. First of all, I'm going to declare a variable here called space. And I will simply I will simply put 100 spaces in there. So this variable is now a string of 100 spaces. I've just used Vim to repeat a space 100 times. So we have now a string in a variable called space that is 100 spaces long. That's actually more than we should ever need for our formatting. So this is a global variable in our script, and we have defined it now. So what I can now do is something like I can do echo. And what I've said is we need those initial spaces here first. And those initial spaces here are actually the maximum number of levels that we want minus the number of levels that we are in. So in this case, 0. So n minus I, where I is 0, so n. So what we can do now is we tell the system that we want the contents of the variable space. However, there is a neat little trick, variable substitution-wise, where we can cut out something from the contents of a variable. So we tell the system do a substring, kind of, starting at 0 and going to, and now the second part can be a variable as well again. So we tell it that we want this one to actually be, and we now use our calculation brackets there, our double round brackets here. And we simply tell the system that we want n minus I spaces there. So it will now calculate that and create a substring of space from 0 to n minus 1, which is exactly n minus 1 spaces. Then we can print the slash. Then we need another set of spaces there. So space again from 0 to, and now what do we need here? We need simply n times 2 spaces. So that is actually how we create that. And then we will simply print a backslash. And as we are, as backslash is an escape character in double quoted strings in Bash as well, we need, of course, 2 because we need this backslash kind of escaped to be printed. Then we need the next line of such a group, which is always one less, so one space less on the left and one more space essentially, or one double more space, so like a level below, in the middle. So what we need to change here is simply that we tell, okay, we want n minus I minus 1 because one less. And here we tell it that we need n plus 1 times 2, so more or less the next level. And if we now execute this hopefully breaks completely and does not work. So what did I do wrong there? Let me see. Oh, I did n times 2. Yes, I did not. I wouldn't have needed n here because that is the maximum amount of spacing. But I would have needed to do I because that's our current iteration there. Okay. So as you can now see, we have our part of the Christmas tree. So now let's do the same trick to draw this divider here. So what we can do actually is we specify something like divider. I'm not sure how this is actually called in English, this part of the tree. I'm not sure how I should call it. So I simply call it divider. So let's do the same trick here again. Let's tell VI that I need 100 of the, and it did not work. Why didn't it work? Let's see. So I want Y 100 of those thingies here. And as you can see, it printed me 100 minus signs. Now I can actually do exactly the same thing. I can do echo divider, and I can tell it to start at 0 and go to, what would it be? It would be, let's do that, n times 2 plus 2, wouldn't it? Yeah. Okay, so that's the amount of dividers that we need. So now we should actually have printed this part. So let's see that we have actually. And we didn't. Why didn't we? Divider 0. That looks strange. Okay, so let's activate a little bit more strict shell error handling. So what we can do, and what I usually do at the start of all of my scripts, no idea why I didn't stop that here like this, is I tell the system that I actually want something like, I want it to exit on errors, so set E. I want it to warn me about unassigned but used variables, if we, for example, misspelled something. And I tell it that I want so-called option pipe fail, and there must be a minus in front of this, pipe fail, which means that if we do something like, for example, cut some file, and we pipe that to a grep foo, and we do something after that, like, I don't know. Then actually, as soon as one of those parts of the pipe fails, the whole thing fails, which usually would not be the case. It only would listen to the initial one, and not to, for example, the one that we piped into. So that is the usual thing that I do here. So exit on error, exit on unassigned use of variables, and do pipe fail. So let's now quickly do that, and it seems I've misspelled divider. Oh yeah, I've done an E here instead of an I. So as you can see, it already helped us. It tells us that I used divider and it is an unbound variable, because usually if you do not set that, you can simply use any variable at any point with any spelling and anything, and if it's not there, it will be assumed to be empty. That is just the way that Bash works normally. So now it should actually show us the divider. Perfect. And now we need the trunk. So what we can do here is we can do, again, use our space from 0 to, what's our trunk there? I guess that's simply n spaces to our trunk, and then the trunk part, and we do that 2 times, and let's do that. And now we have a Christmas tree with a trunk, and we can specify how large or how small we want our tree simply by changing the number of those groups here. And let's quickly see if we can't actually add some sort of ornament there to have at least the random generation part of Bash explained as well, even though we are more or less ready here. So randomness in Bash is actually simply done by accessing a magic variable called random. So random. So if I simply do that, it gives me a random number, a random integer between 0 and 2 to the power of 15, I think, like 32,000 and something something. So let's see, what is 2 to the power of 15? Am I right? Yeah, 32,760, 86. Yes. No, 68. So this is the maximum random number that you will get. So essentially a 16-bit signed value, the positive part of it at least. So that's actually a random number that you get every time. So if I do that again and again and again, you can see that you get different sized random numbers. And yeah, all of those are actually there. You can actually initialize the random seed to a random value that you want by setting random. So if you write to that, like for example, I do here 23, and now I call random, and I call this, and then I do that again, and I call again random, you can see that you get exactly the same numbers. So this is actually the way to seed your random number generator, but usually you don't need to, because for what you are doing usually with random, except you want something repeatable. So if you really only want random numbers for some sort of a little programming exercise or a script, then just get them from random and you are good to go. Of course, those are not cryptography safe. I don't think I need to tell you that. So let's quickly see how we could do that with the ornaments. First of all, I guess we need an ornaments function again, as always, because we need to kind of do now some iterations. So what we get here is the number n of spacings that we need there. So let's take that from the variable from the first argument that we are supplied. And now we are actually doing something like we are doing output, for example, which is an empty string. And we will now do a simple for iteration for I equals 0, I is less than n, and I plus plus. Then we want to do done. So we are doing this in a very uncreative way. As always, we are simply asking the system if And now if is an interesting construct as well, because we have those brackets here that we are using with if, and essentially what is happening here is this is a call to the test function. So if I do something like test or men test, for example, we should, okay, that's not good readable. However, what we can actually see here is there are different things you can do with test. For example, I can do test 23 is less than 42. And if we see the exit code of this one, it is actually 0, which in Bash means it is okay, it exited positively. If we do it the other way around, like 42 and 23, we will see that the exit code is 1, so this actually failed. And what actually happens if you do the square brackets here, it's a call to test. It's just a shorthand for that. So usually what you do is you have if, and then you have a command here, and if this exits negatively, it will not match that if, and if it exits positively, so with a 0 exit code, it matches this if branch. So what we can actually do here now is we can do give me a random value. And if this random value is less than, and now we use our calculation possibilities here again, is less than 2 to the power of 15, so the maximum value of the random divided by 10, so we actually have a tenth of it, which would be kind of 10%, as we did before always, then this is the way you do an if, then we do something here, else we do something else, and the end of an if block actually is an fi. It's a just inversed if. So if we match this, we actually want to print out an ornament. So what we then will do is we will do output equals output. So the variable there and an O, for example, as an ornament there. And otherwise, we would simply do output equals output followed by a space. So we add a space to it. And in the end, we simply do echo output there. So let's do that. So now we should actually have created a random ornament there, and now we should be able to simply replace those second spacing call here with our inline call, which is $and 1 round bracket there, and we simply do ornaments, and we put in there this this variable here that we calculated, and let's just to ensure that it is not escaped weirdly, do it like that, and now that. So essentially we are calling the function here now and putting this information in it. So we need another bracket there, and I hope I didn't miss a bracket. So what this should now do is, and I have somewhere a brace too many, like this exactly. And as you can see now, we have a Christmas tree with random ornaments there. So let's maybe do an 8 tree here. And as you can see, random ornaments there. Yeah, I hope you liked this session as many or as well as the others, and you had fun learning something about a different language each day, doing this each day in the 24th days of December, the 24 day of the for the 24 days of December, like that. Yeah, I hope you had fun and learned something, and I hope I will see you in the next one tomorrow. So see you. Bye.